Assalamualaikum and hello everyone. Today we are from Group 5. We are presenting our project on predicting internal mark volume from physical characteristics. In this study, we use RStudio to analyze the real data and find out how different body traits connect to mark volume. Before I dive into the details, here is our team members. First, Najla Auni, which is me, and then Izzati Liana, Nazir Hanis, and also Farah Adila. Together, we collaborate to process this dataset and run the test statistics. To start with the background of our study, differences in human body frame make medical and dental planning difficult. For example, dentists face real challenges guessing internal mark volume from external traits, which can lead to mistakes like choosing the wrong tool sizes during procedure. Because of this, the purpose of this study is to look at how an individual mark volume relates to their head, weight, gender, and also age, so medical worker can make more accurate predictions. Based on our data, we expect to see that these physical characteristics significantly affect an individual's mark volume.
Hi, I am Nazira and now I will explain the dataset. The dataset selected for the study is mark volume by measurement consisting of a sample of 61 human subjects and a related physical measurement. Our dataset consists of 5 variables, which are most value, age, gender, height, and weight. Mark value, age, height, and weight are quantitative variables. Ratio scale by gender is qualitative variables. Ratio are nominal. So, we perform 4 test analyses. The first one is one sample hypothesis test to determine whether the mean of the mark value is 55Q. The second one is correlation test to determine whether there is a linear correlation between height and weight. The third one is a simple linear regression to determine whether mark value depends on height. Finally, we conduct a chi-square test to determine whether gender and age group are related.
So now I will explain the first test, which is one sample hypothesis testing. So our objective was to determine whether the average mark volume of an individual exceeds 55.0 cubic centimeter. Our null hypothesis states that the mean is exactly 55.0, while our alternative hypothesis states that it is greater than 55.0. By executing this in RStudio, we obtain a sample mean of 16.270 and a sample standard deviation of 16.878. This results in a test statistic p-value of 2.439 and a p-value of 0.009. Since our p-value of 0.009 is less than our significant level of 0.05, we reject the null hypothesis. Therefore, there is sufficient evidence to conclude that the true mean mark volume of an individual is significantly greater than 55.0 cubic centimeter.
Next, I will explain the correlation analysis. The objective of this test is to determine whether there is a linear correlation between height and weight at a 95 confidence level. In this analysis, height is independent variable or x, and weight is dependent variable or y. The null hypothesis states that there is a non-linear correlation between height and weight, while alternative hypothesis states that a linear correlation is. Using RStudio, we obtain a test statistic of 5.127, a correlation coefficient R of 0.555, and p-value of 3.4 times 10 to the power of negative 6. Since the p-value is less than significant level of 0.05, we reject the null hypothesis. Therefore, there is enough evidence to conclude that there is a linear correlation between height and weight. Looking at the scatter plot, we can see that the points to upright indicate a positive relationship between two variables. The correlation coefficient R 0.555 indicates a moderate positive correlation between each value because each value falls between 0.5 and 0.8, which is commonly accepted range for the monetary correlation. This means the relationship is noticeable, but it is not very strong. Therefore, as height increases, weight also tend to increase, but height alone cannot perfectly predict a person's weight because there is another factor weight also influencing.
Now, I will continue for the regression test. We investigate the relationship between height and mouth volume, where height is the independent variable x and the mouth volume is the dependent variable y. In the R code, the variables are first assigned, followed by generating a scatter plot using the plot bracket function and adding the regression line using add line bracket to visualize the relationship. From the scatter plot, we can observe that a positive linear relationship where mouth volume tends to increase as the height increases. So a simple linear regression model is then created using the LM bracket function to estimate the relationship between two variables, and we obtain a coefficients of B0 equals to negative 44.711 and B1 equals to 61.379, giving the regression equation, which is y hat equals to negative 44.711 plus 61.379x. This means that for every 1 minute increase in height, the predicted mouth volume increases by approximately 61.379 units. Then the coefficient of determination r squared equals to 0.153 shows that only 15.3% variation in mouth volume is explained by height, indicating a weak linear relationship. The standard error SB1 equals to 18.766 represent the uncertainty of the estimated slope, while the regression standard error equals to 15.660 shows that the actual values differ from the predicted values by approximately 15.660 units on average. And finally, a t-test is performed in the R analysis to test whether the height is significantly affects the mouth volume. The test statistic that we obtain is t equals to 3.271, which is greater than the critical volume value of 1.96. Therefore, we reject the null hypothesis and conclude that height has a significant effect on mouth volume, although the relationship is relatively weak.
Moving on, I'll be explaining on the net test analysis, which is the chi-square test. So the objective of conducting this test is to investigate the dependency between an individual's age group and their gender. So our null hypothesis for this test analysis is that an individual's age group and their gender are independent, while our alternate hypothesis is that an individual's age group and their gender are dependent. So this is a data analysis that we have obtained after conducting the test. As you can see here, this is the test statistic table, as we have the observed count, expected count, and also the test statistic value for each cell. So after calculating all the sum for each test statistic, we can get a total test statistic value equal to 0.01805. And in this calculation, we use a significance level alpha equal to 0.05, and we calculate the degree of freedom, which is equal to 1. And after this calculation, we refer to the standard chi-square distribution table, and a test statistic value of 0.01805 will yield a p-value more than 0.10. And by using our studio, we can get an exact p-value, which is equal to 0.893. So in conclusion, since the p-value is more than a significance level value, thus we fail to reject H now. Hence, at alpha equal to 0.05, there is insufficient evidence to support the claim that an individual's age group and their gender are independent. In conclusion, through this project, we learned the data analysis workflow in RStudio, learning how to clean a dataset and interpret p-values and t-statistics. Our most interesting findings reveal a moderate positive relationship between height and weight and confirm that height significantly impacts mouth volume, which averaged over 55.0 cm cubed to help improve dental treatment accuracy. In contrast, our chi-square test proved that an individual's gender and age group are completely independent. Ultimately, this study taught us how to use real-world dataset metrics to make objective, evidence-based decisions rather than just guessing. With that, we conclude our presentation. Thank you for watching and have a good day.